Hello everyone, and welcome to Day 2 of your center's week-long campaign to help you better understand vaccines and how they protect you from viruses. First, let's explore what a virus is with a short visit with the science. A virus is a microscopic infective agent made up of protein and genetic code that can only be visualized with a powerful microscope. They are able to multiply only within a living cell, like the mucous membrane cells of your nose, mouth, and eyes. A virus consists of a genetic code of nucleic acid covered in a protein coat with spikes. The spikes, made of what's called glycoprotein, are used to attach and enter the cells. Coronavirus was named corona, meaning crown, due to the shape of the ends of the protein spike, which when magnified looks like a crown. The crown-shaped end of the protein spike frequently become shapeshifters, adjusting their shape in order to connect to your cells. Once the protein spike connects with one of your cells in your mucous membrane, it binds with your cell. The virus mimics a protein that our cells expect and gains entry. Once the virus enters the cells follow the instructions to replicate and release copies of the virus that begin to infect more cells. The immune system begins to react with an inflammatory response. The more intense or robust the inflammation becomes, the more serious the symptoms become. If the virus gets to the cells in your lungs and starts destroying cells, the inflammation can be so serious that the lung tissue swells, causing shortness of breath. This lack of oxygen can lead to death or require mechanical ventilation. As the virus invades the blood vessels of the lungs, dangerous blood clots can occur. The genetic code of viruses can be either DNA or RNA. COVID-19 is a single-strand RNA virus which looks very different from the DNA or genetic code in your body. Viruses continually mutate and develop variants. To understand this picture shows a single strand of RNA, the internal genetic code of COVID-19 and many other viruses. While it's not important to understand the four components of RNA, cytosine, guanine, adenine, and uracil, labeled C, G, A, and U, it helps to explain how variants occur. These four components are arranged in a set order or sequence in the virus's genetic code. A mutation or variant occurs during the process of duplication or multiplying of the virus. The change in the order of the sequence of these components are errors. These errors during multiplication of the virus create the new mutation or variant. Science has shown these errors or mutations occur naturally and are random. Some variants are weaker than the original and fade away, and some are stronger, more contagious, and may change the symptoms. As we have seen with the early variants of COVID-19, symptoms were specifically respiratory. The addition of gastrointestinal symptoms, like vomiting and diarrhea, were added as mutations occurred, changing the behavior of the virus. Currently, there are over 100 variants of COVID-19. Thankfully, most are not variants of concern. They are all named in groups with the Greek alphabet: alpha, beta, gamma, delta, and others. Science categorizes them by threat level: variants of interest, variants of concern, and variants of consequences. The current Delta variant is a variant of concern, predicted to be a variant of consequences soon. So, what is a vaccine? When your body encounters a new virus that you have not been vaccinated for, your immune system carries out a three-pronged approach. First, your white blood cells, the T cells, attack the invading virus directly. A few days later, your B cells start producing antibodies, and then components of your immune system, like the macrophages, dispose of the infected cells and debris. Lastly, your immune system takes a picture and makes a memory of the invading virus. Historically, vaccines were a weakened or inactive part of the virus it was intended to protect you from, used to trigger an immune response in your body. Older vaccines stimulated the immune system almost identically to a natural response, starting with your T cells' direct attack. Newer vaccines, like the ones for COVID-19, contain a replica or instructions to replicate a small part of the virus. COVID-19 vaccines work by instructing the body to produce a replica of COVID-19's protein spike. This replica tricks your immune system in believing there has been a viral invasion. Using the vaccine skips the initial response of your immune system and jumps right to stimulating your B cells to produce antibodies. What are the advantages of using a vaccine to kickstart the antibody production rather than waiting to be exposed to the virus and develop antibodies naturally? There are several advantages to using a vaccine to develop antibodies and immunity. The most important advantage is to skip the initial assault and inflammation process of your immune system's initial attack on the virus. This initial phase of your immune response is the stage where symptoms, especially serious symptoms such as shortness of breath, hypoxia, and blood clots, may occur. Using a vaccine has a milder immune response, skipping the most symptomatic phase and getting directly to the task of producing antibodies and committing the protein spike of the virus to memory. Additionally, studies that have occurred since the 1950s have shown that antibodies developed by vaccination tend to stay with us longer, and some vaccine antibodies, like for measles, mumps, and rubella, can protect us for decades. While we do not know how long immunity will last with the COVID-19 vaccine, we do know that the vaccine trials have been ongoing for over 10 months with strong antibody response. We also know that antibodies for COVID-19 disease contracted naturally generally start declining after 60 days. This is why we have unvaccinated people who have contracted COVID-19 with symptoms more than once. We have all witnessed cases of vaccinated people testing positive with COVID-19 with little or no symptoms. If vaccination can minimize the likelihood of serious symptoms from COVID-19, why wouldn't you take the vaccine? I hope this video has helped you gain a better understanding of viruses like COVID-19 and the advantages of vaccination.